Okay, so we're going to talk about adding and subtracting fractions with unlocked denominators. We've kind of already covered most of it, but we're going to just kind of do a run through. Step 1 is to find the LCM. Step 2 is to make equivalent fractions. Step 3 is to add the numerators and denominators and know that the denominator will stay the same. Step 4 is to fix your answer. So if it's an improper fraction, then you're going to tableau, which means divide, top in, bottom out. If it needs to be reduced, then you're going to make equivalent fractions by reducing. So remember, an even over an even will always reduce. I'm sorry about the shadow. I can't get it to go away. Okay, so 1/2 plus 3/8. So the first thing that we're going to do is we're going to find the LCM for the two denominators. So we're going to do a tic-tac-toe board for 2 and a tic-tac-toe board for 8. Okay? And you're going to list all the multiples, which means you're going to skip count, do the multiplication facts of 2 and 8. So 2, 4, 6, 8, 10, 12. So I'm just going to stop there. And then I'm going to do 8, 16, 24. Well, I'm going to stop because 8 is bigger than 2. So I know that my least common multiple, my LCM, cannot be smaller than my biggest number. So my denominators were 2 and 8. So my LCM has to at least be 8. Can't be smaller than 8. Well, as I'm looking, they both have an 8 in common. So the smallest number they both have in common is the LCM. So that means the LCM for this pair of fractions is going to be 8. Okay, so that was step 1. We found the LCM, the least common multiple. Smallest number both denominators have in common. Now we're going to make equivalent fractions using this LCM as the new denominator. So I'm going to make 8 and that one over 8. So now we have two fractions with common denominator. I have 1/2 equals something over 8. Okay, now with equivalent fractions, remember, we know 2 equals 8. That's what we know. What can you multiply 2 by to get 8? 1, 2, 3, 4. So I know 2 times 4 equals 8. So the golden rule, whatever I do to one, I have to do to the other. So I have to multiply by 4 for the numerator. And 1 times 4 is 4. So 1/2 is equivalent to 4 over 8. So there's an equivalent fraction. Now, 3/8 equals something over 8. I know 8 equals 8. The only way for 8 to equal 8 is times 1. So that means this 3 is going to stay the same. It's not going to change. Okay? All right. So now the next step was add the numerators. Denominator will stay the same. Now I have equivalent fractions. This one is no longer necessary. X it out. So now we're going to add, we're adding 4 plus 3 because we're only adding the numerators. 4 plus 3 is 7. The denominator will stay the same. 7/8. Okay, that is not improper, so I don't have to tableau. It's not an even over an even, so I know for a fact I don't have to reduce it. But then when I look at it, 7 and 8 don't have anything in common. So we're going to leave it alone. That's it. That's all we're going to do. Okay, 7/8 minus 1/4. We're going to first find the LCM. So again, we're going to take the two denominators and we're going to do tic-tac-toe board. My denominators are 4 and 8. Well, 4 times 1 is 4. 4 times 2 is 8. I can stop. I don't have to do any further as soon as I find one. Okay? If you need to fill it out like we did over here, fine. Fill it out all the way to the end. That's fine. If you can get it right off the bat, perfect. Okay? Because I know 4 goes into 8 2 times. So that's how I knew I could stop. All right? So we found the LCM. The LCM is 8. So we're going to make equivalent fractions with 8 as the denominator. 7/8 equals something over 8. That one's going to stay the same. It did not change. 7/8 equals 7/8. But 1/4 equals something over 8. That one's different. I know 4 is equal to 8 by multiplying it by 2. So I'm going to hit times 2 here and times 2 in the numerator, because whatever I do to the denominator, I have to do to the numerator. And 1 times 2 is 2. I am done with this set of fractions over here. I made my equivalent fractions and I'm done. Now it says add or subtract, add the numerators. Okay, I didn't put subtract. Add or subtract the numerators. Denominators will stay the same. Okay, well, this case we're doing subtraction. So 7 minus 2 is 5. The denominator is 8. Again, check to see if you need to do anything. This is not an even over an even, so I don't need to reduce. 5 doesn't go into 8, so another point meaning I don't need to reduce. So we're finished. Okay? All right, let's look at some examples now. Five over 6 minus 1 over 3. Okay, so the first thing we're going to do is find the LCM. So we're going to make a tic-tac-toe board for 6 and 3. So let's list the factors for 6 and 3. I'm going to start with 3. 3, 6, 9. What would your LCM be? Have you already found it? The LCM is 6. Okay, so we're going to make equivalent fractions with 6 as the denominator. Okay. All right. 5 over 6 equals something over 6. Well, 6 equals 6. So that means 5 equals 5. All right. 1/3 equals something over 6. I know that 3 is equal to 6 2 times. 3 times 2. So the numerator I have to multiply by 2, and 1 times 2 is 2. This is a subtraction problem. I'm done with this fraction. So 5, 6 minus 2, 6. If I have 5 and I take 2 away, what's left? Okay, that'd be 3, and the denominator is 6. Okay, so look at this, 3 over 6. Here's where we talked about fixing the fractions. That's not an even over an even. 3 is an odd number, but 6 is an even number. It's not improper. The numerator is not bigger than the denominator. But what I know about this fraction is I know that I can multiply 3 times something and get 6. So that means I'm going to make an equivalent fraction. Okay. Now, if I know I can take 3 and multiply it by something to get 6, 3 times what equals 6? Times 2. So I'm going to divide by 3. Okay. 3 will go into 3 one time. 6 will go into 3 2 times. 3 6 is 1/2. Okay. All right. 3/4 minus 5/12. Find the LCM. 4 and 12. Okay. What's the LCM going to be for 4 and 12? Remember, it can't be smaller than the biggest number. All right. So 4, 8, 12, 16. Oh, you should have picked 12 as the LCM. So now you're going to make equivalent fractions with 12 as the denominator. 5 over 12 equals something over 12. That one stays the same. We don't have to do anything to it. So the only fraction I have to change is 3/4. 4 equals 12. 1, 2 times 3. So I have to multiply the numerator times 3. And 3 times 3 is 9. Now you're finished with that fraction. So now you're going to subtract. All right. You should have said 9 minus 5 is 4. The denominator is 12. All right. 4 over 12 is an even over an even. So here's what you have to think about. I know 2 will go into both 4 and 12 because 2 goes in every even number. But look at 4 over 12. Can 4 times a number equal 12? Yep, 4 times 3, right? So if I divide the top and the bottom by the number 4, that will completely reduce my fraction. So I'm going to divide the top by 4 and the bottom by 4, because equivalent fraction says I do whatever I do to the top, I do to the bottom. Whatever I do to the bottom, I do to the top. So 4 divided by 4 is 1. 12 divided by 4. 4 times 3 equals 12. So 12 over 4. 12 divided by 4 equals 3. 1/3. Okay? It's just all about how you look at the fraction. Okay? If you know it's an even over an even, it'll divide by 2. But if you just divide it by 2, you might have to divide it several times to actually get your answer. Okay, 1/3 equals 1/3 plus 5/6. My denominators are 3 and 6. Okay. Do I need to do this again since I've already used 3 and 6 as the denominator? The answer is no. If you've already done the tic-tac-toe board for the same 2 denominators, why do double the work? I can look up above and see that I've already done 3 over 6. So my LCM is going to be 6. So I'm going to make equivalent fractions with 6 as my denominator. 5 over 6 equals 6, so that means this fraction is going to stay the same. And the only fraction I have to change is 1/3 equals something over 6. So I know 3 will go into 6 2 times. 3 times 2 equals 6. So I have to multiply the numerator by 2. 1 times 2 equals 2. We're adding on this one, so we're finished with those, and we're just going to add the numerators. 2 plus 5 is 7, and the denominator is 6. Now, looking at that, I know that is an improper fraction because the numerator is larger than the denominator. So I'm going to Tybo. That means 7 divided by 6. Top in, bottom out. Top on the inside of the house, bottom on the outside of the house. 6 will go into 7 just once. 7 minus 6 is 1. This 1 becomes the numerator, and 6 is my denominator. So I have 1 and 1/6 left over when I add my fractions. Okay? 5/6 plus 1/12. So I need 6 and I need a 12. So I'm going to start with my smaller fraction because I might run into the big fraction, right? 6 times 2 is 12. Looky there. My LCM is going to be what? 12. So I make 2 fractions. 5/6 equals something over 12. And 1/12 equals something over 12. Well, 12 equals 12, so that means 1 is going to equal 1. 6 equals 12 2 times. So that means I'm going to do times 2 at the numerator. 5 times 2 is 10. We're adding, but we're finished with those fractions over here. So I'm just focusing on 10/12 plus 1/12. 10 plus 1 is 11. The denominator is 12. Okay, 11 over 12 is not even over an even. 11 is as close to 12 as you can get, so there is no way to reduce it. There's nothing they're going to have in common. Okay, let's do a couple more. All right, I want you to find the LCM of 8 and 4. Okay, you should have gotten 8 as the LCM. Okay, which means 1/8 is going to stay the same. 4 will go in 8 times 2. And then the numerator times 2, which is 6. Mark out that fraction. 1 plus 6 is 7. And the denominator is 8. Okay, find the LCM of 10 and 2. Okay, you should have gotten 10. Make your equivalent fractions. Okay, 9/10 is going to be equal to 9/10. That one's not going to change. But 1/2 equals what over 10? Okay, 2 times 5. So times 5 here. All right, so we're going to now mark out this fraction, the pair of fractions actually, and you're going to subtract 9/10 minus 5/10. All right, you should have gotten 4/10. That is an even over an even. So now you have to look at it. Can 4 times a number equal 10 evenly? Okay. If your answer is no, then what other number can we reduce it by? Reduce it by 2. So make an equivalent fraction for 4 divided by 2 equals what? And 10 divided by 2 equals what? Okay. 4 divided by 2 is 2. And 10 divided by 2 is 5. So 4/10 is equal to 2/5. Okay. All right. What's the LCM for 1/3 and 1/4? You should have gotten 12. So on this one, we're going to have to change both fractions because they didn't have anything in common. So 1/3 equals something over 12. Well, I know 3 times 4 equals 12. So I'm going to say times 4 here and times 4 with the numerator. And 1 times 4 is 4. 1/4 equals something over 12. I know 4 times 3 equals 12. So I'm going to multiply the denominator times 3 and the numerator times 3. And then 1 times 3 is 3. We're finished with this fraction. So now you have 4/12 minus 3/12. Now, what would your answer be? Okay, you should have gotten 1/12. Okay. All right, find the LCM of 1/10 and 2/5. Okay, the LCM is 10. 1/10 is going to stay the same, and 2/5 is going to be something over 10. Now, I know 5 times 2 equals 10, so I'm going to multiply the numerator times 2. 2 times 2 is 4. We're finished with this set of fractions over here. So now we have 1/10 plus 4/10. All right. You should have gotten 5/10. Now, look at 5/10. That's not an even over an even. But what do we know about the number 5? Can 5 go into 10 evenly? Okay, so how many times will 5 go into 10? Twice, right? So I can divide the top by 5 and the bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So there's the 2 times 1/2. Okay. All right, so let's now look at a couple of models. I'm going to do a couple of addition and a couple of subtraction, and that'll be all for today. And then we'll move on into more pictorial models starting tomorrow. So 1/2 plus 1/3. So this would be 1/2. Okay, 1 out of 2 are shaded. this would be 1/3. Okay, so what I'm going to do is I'm going to make a third model. And I'm going to give it 1/2. I'm going to shade it. And then I'm going to take that half and I'm going to break it into 3 sections. Now, looking at that picture, how many are shaded now in my equals? 3 out of 6. Is that correct? No, because I only have a half shaded, right? So that can't be it. Okay, you have to look at the whole picture. I did a half. Now I have to do a third. So now I have to shade in this one. So now I have 1/2 shaded and 1/3 shaded. A vertical and a horizontal. Now look at it and how many are shaded. 4 out of 6. Okay, so it's all in how you look at it. You can't just do one part of the picture. Okay, I did a half, but I also had to do a third. Just because I drew the lines didn't mean that I don't have to color it in. So I have 1/3 shaded and I have 1/2 shaded. And altogether there are 4 shaded out of the 6 total models. Okay, 2/3 plus 3/5. So here's my 2/3 shaded. And now here is my 1, 2, 3 out of 5 shaded. All right, so now we have to be careful what we do. So I'm going to make my next model. Okay, and I'm going to make my third horizontally. And I'm going to shade in 2. Now I'm going to make my vertical. Okay, 1, 2, 3, 4, 5 columns. But now I have to make sure that I shade in 3 out of 5. So that means this whole thing is shaded, this whole thing is shaded, and this whole thing is shaded. Now, looking at my picture, how many total models did I shade in? 13 out of 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then 14 and 15 were left unshaded. Okay? All right, so now let's look at some subtraction. Subtraction is a little differently, done a little differently. You have to be able to focus on the picture itself. So look at just the shaded pieces. I have 1, 2, 3, 4, 5 shaded out of 6, 7, 8. So I have 5 out of 8 shaded. And then we're going to take and we're going to subtract this. You have to visualize is columns. So I have 1, 2 out of 1, 2, 3, 4. Okay. Now, what is not X'd out or circled is the 1. 1 out of 8. Okay, we're looking at what's not X'd out. Okay, so I have 1 that did not get messed with at all out of 8. Okay, so let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 are shaded out of 19, 20, 21, 22, 23, 24, 25. 18 out of 25 are shaded. Now, look at the X's. You have to look at the whole column. So that's 1, 2, 3 columns are completely X'd out. So that's going to be my numerator. And my denominator is going to be what? 5. Okay, now look at what is not circled or X'd out. What do I have left over? 3 out of how many total squares? 25. Okay, again, we're going to look at the models more on Tuesday, but I just wanted you to get a kind of a feel or understanding for what they look like. Okay, make sure you watch the video all the way to the end and you've answered all the questions.